Clean water. It might be the only thing in the world we all agree is important. But if it's something we all value, how come clean water isn't everywhere? And how come some of our biggest supplies of fresh water are drying up right before our eyes? This isn't an isolated incident. Desertification is a problem plaguing the globe. And worse yet, the water we do have we don't seem to value, and it gets dirty and polluted. Well, why is that? Well, there are physical, chemical, and biological aspects of water pollution. And in this video, I want to show you some solutions and not just focus on the problems. But before we begin, there's a couple things I want you to keep in mind. One is that energy flows and matter cycles. And excess is what creates our biggest deficiencies. Let's start off by looking at this illustration of a water cycle. Don't worry, you can come back and look at this if you need, and we're going to talk about each one of these aspects as we move forward. First, we have evapotranspiration, where the water literally leaves the ground. Trees breathe it out, and all of this water in the air, which is powered by the sun, the whole system is powered by the sun, the clouds rise up and fall back down to the earth. And water has quite a journey. The power of water should not be underestimated. As it falls, it travels a winding journey, and it sure can gather momentum. And with all that energy, it creates a powerful force, one that can erode mountains. And I'm not just talking about geological time here, over the course of hundreds of years, no. Water can alter a landscape almost instantaneously. Flash floods are common in areas with big collection basins, with little areas for the water to seep into the ground. And as that water travels, it's incredibly powerful, carrying entire trees, boulders, and covering the stream bed. Now, most erosion starts off small, like this gully. But these patterns and fractals of water, they compile very quickly, and entire mountainsides can be eroded within generations. All the sediment, a significant polluter to streams. And when we try to build next to these waterways, we often suffer significant consequences. It seems like every week we're seeing another significant flood someplace in the world. And it is all that surprising when we build in flood areas and we drain all the wetlands that provide us our flood protection. What's our solution? Cover things in concrete and try and get that water away as fast as possible. And when we lack areas for water to seep in, that's when the floods happen. So to understand this better, let's take a look at this groundwater model. We can see the water flowing down from the tops of the highlands and emerging in the stream. They might be small springs, you might see them as icicles, or they feed into giant rivers. The rate of which depends on soil. And no, not all dirt is made the same. It's very different. Now we could dive deep into soil, but let's just graze the surface here. We've got three main particles: sand, silt, and clay. The size varies significantly. The bigger the pores, the faster the water can move down through the soil. So sand moves very fast. Clay, it's really slow. And of course, rock can hardly move through at all. Now, water doesn't just flow down, it flows side to side through electrical forces that we call capillary action. So this water is spreading out as it falls down in the soil. Here's another visual representation. You can see the differences between sandy loam. Loam is just a mixture of soil. And you see how slow it moves through the clay. And if water is flowing down, it hits these confining layers. That's what we call an aquifer. And these can be in multiple layers. There's not just one. The deeper they are, the longer they tend to take to recharge. And humans have tapped in to these aquifers in the form of a well. Now, we aren't the only species in the world that are tremendous water engineers. We can look at none other like our friend the beaver for insights into how to manage water. When a beaver makes its dam, it doesn't stop the water, it slows it down. It allows it to be spread out over the landscape where it can provide hydration for a vast number of species. So, how can we be like the beaver? When we see our stormwater rushing away through these storm drains, we consider this standard practice. But these rain gardens and simple curb cuts are a great first step, which instead of sending all that water down our drains and flooding the rivers, we soak it and irrigate our landscapes. They can be planted. They can be very easy to build yourself. Simply just a hole in the ground that you allow it to sink in. Most of us are familiar with rain barrels. And these are a great way to collect water right off your house. He's using something called a first flush diverter that helps to clean it out from debris that might accumulate from the roofs. A cistern is basically a giant rain barrel that most of the time is buried. And these cisterns have water coming in, you got overflow pipes, you got an area for your pump. And these are a great way to store a large volume of water. Now, cisterns have been around for a very long time. And some of these cisterns are nicer than any house I know I'll ever live in. I mean, look at those stone columns. Just absolutely beautiful. Now, another way to store large volumes of rainwater from gutters are these aqua basins. If we take a look at what the Aquascape Foundation did here to capture rainwater for this village in Ghana, the water falls down and collects in these aqua blocks where it can later be pumped out. Now, if we want to make this drinking water, it does need an extra step of filtration. And these biosand filters are a terrific way to filter out fine sediments along with the biological layer, that schmutz or however you say it. That's biology, and biology is the best way to treat biology. Now, humans have a long history of capturing rainwater. Let's travel to Bali for one of my favorite examples. You see these terraces? The water flowing from one to the other travels a far distance and allows it to be used for the most amount of crops. These terraces can be used to restore deserts, like this example in the Lush Plateau in China, where they transformed this barren landscape into a lush oasis. Well, how'd the land get there in the first place? When we strip the land of all the vegetation and the sun beats down on it, it dries up the plants. And you get this deprecating cycle where things keep getting worse. Well, we can intervene with very simple tools. This isn't complex engineering. We're not building the Hoover Dam here. We're digging holes. And these holes allow water to collect, and the water sprouts seeds. And the more plants, the more avenues for that water to get back down into the ground, the more clouds are breathed, and eventually you get this vast network, this hydrologic corridor that transforms these barren landscapes into lush oases. Simple rock check dams like this in Al Baida, Saudi Arabia. It very rarely rains in the desert. Every couple years they might get a couple inches. Most of the time it floods and washes away. So these simple structures allow it to be spread out and soaked into the landscape. So you can see this was a barren landscape. Now, I prefer it in Michigan, but that's a big upgrade. Now, if we want to take a close look at how some of these systems work, we should study P.A. Yeoman, who developed this idea of keyline design. And a common principle in here is making a series of dams to slow the water down. Where the water collects in the valleys, slow it down and spread it out to the ridges. You can see this in action at his farm. Now, I had been familiar with this farm, I'll be honest, before this video. I'd seen many pictures of this. And it's really impressive to see the rows of trees and all the different ponds. But I was just blown away when I started exploring this region to see how widespread all these ponds are. You got these neighborhoods that are based on the same keyline design principle with ponds. That's actually Yeoman's playground. And if you look at this landscape, there's ponds everywhere. The homes, they're all built using this principle of efficient design. The ponds collect the rainwater so it can be used later on. This is a pretty dry region, and it seems pretty lush to me. These ponds, again, they're everywhere. And I was even more impressed when I looked at it on a traditional 2D map. The ponds kind of blend in with all the trees, but just look at the sheer number of these. It's truly inspiring. If we travel to Wisconsin, we see another protege of P.A. Yeoman's work. Mark Shepard at New Forest Farm has put these principles into practice, where he's got these rows of trees, growing crops in between like asparagus, vegetables, he grazes animals. The water is all spread out and soaks into the landscape, a self-sustaining ecosystem. Or we can travel to Austria, to the Kramatterhof, where Sepp Holzer and his son Joseph have transformed this simple farm in the Alps into a lush oasis of dozens of ponds. And we can take a look at these floating gardens. In their ponds, they grow all sorts of vegetables. In a sense, they're practicing aquaponics, which is used pretty widespread today actually for a lot of vegetables, especially salad greens, where you get this water environment full of nutrients and the roots go down there and they just drink them right up. But this isn't some new innovation. This stuff has been around for centuries, if not longer. If we travel to Central America, we can see these chinampas, as Andrew Millison, the legend here, illustrates. These chinampas were dredged out from the lake. Layers of organic matter implanted. So they take all that fertile stuff and they grow on it. Many people in Central America, like one of my favorite examples, on Lake Titicaca, you had all these islands made out of straw just floating there. I mean, who wouldn't want to live there? I can't swim very good, maybe not me, but it's amazing. But it's been done all over the world, like the marsh areas in southern Iraq. These huge cities and villages made out of straw. Unfortunately, many of these wetlands were drained by Saddam. However, they are making a fierce comeback. If we explore perhaps the opposite side of the spectrum of too much water, we can look at the Netherlands. What did the Netherlands do? They built all these canals to elevate lands, and it's incredibly fertile ground. The Netherlands is one of the most productive agricultural countries in the entire world, especially compared to its size. The canals provide opportunity for irrigation, but again, all that fertile sediment that covered those bottom lands are great to grow on. And it's a great place to live. However, it's not foolproof. They do need to pull a bunch of bikes out of the canals. Most canals don't need bikes to be pulled out of. They need to be dredged, like the Erie Canal. And here they use big machines to pull out the sediments, and they put them in acetylene ponds because the faster water moves, the bigger sediments it can carry. So they let it settle out where it can perhaps be applied to the fields. And again, this isn't a new concept. Farmers have been doing this for 40 centuries, especially in East Asia. We just have fancier tools and equipment now to do it. I've actually used one of these giant excavators before. They're tons of fun. All of these tools can help us manage our nutrient cycle, particularly phosphorus with sediments. Phosphorus binds to the sediments. It's a natural process of erosion, but if we accelerate that process of erosion, we can also accelerate the process of regaining our fertility using machines. And there is an unfortunate reality that plastic and other debris end up in the water, but we've got tools that we can pull it out. Prevention is always the best though. Now let's take a minute to think about water chemistry. Water is a polar molecule. It's got a positive and a negative side. And that means it's a great dissolver. It can pull particles apart. Here's an illustration of salt, which also has positive and negative ions in it. But there's all sorts of different chemicals that water can dissolve. That's why that hydroponic system works, because water can be dissolved. And there's one particularly treacherous organism that loves all these nutrients. Plankton! Despite Plankton's hard feelings about himself, he is loved by the community. He's just loved to be eaten. And so all these nutrients in the plankton provide fish food. You don't want a body of water with no nutrients in it, because nutrients are life. It's the excess that creates deficiency. And when they die, all that organic matter falls, and when it decomposes, it consumes oxygen. Fish need to breathe oxygen. If you remove all that oxygen, the fish can die. Now, for big bodies of water, we might use something like an aerator. And oxygen is crucial for the nitrogen cycle. We'll skip over most of the details for now, but just remember, the nitrogen cycle is a natural process. Now, when we get a big concentration of nutrients, like the runoff coming from this factory farm, we can get explosions of algae, particularly the toxic red tide variety. But when we have these big concentrations of nutrients, that leaves a tremendous opportunity to use something like a bioreactor, which take all that energy and in the absence of oxygen, releases natural gas. If we look at a large-scale wastewater facility, we can see how they treat and clean the water. It's a very elaborate process using settling tanks and flocculants. And these flocculants help to bind up all the particles that are dissolved in solution. And because they're electrical charged, they will never fall out on their own. And they clump them together like clouds and make them fall down. Now, chemicals can be used, and perhaps they should, in wastewater facilities. But wetlands are the answer. They can even be used to treat acid mine waste. And something that's particularly cool are floating wetlands. You don't even need to dig them out. If you got a big body of water, you can float them. And these floating islands provide all sorts of habitat for aquatic organisms and allow things like the nitrogen cycle to properly occur and can be used in a wide variety of applications. Provide habitat for animals and have been used even to treat wastewater. Another area where nutrients typically concentrate in water are fish farms. You get these big pens, all this feed gets added in, and there's typically a toxic environment around there because the nutrients aren't fully utilized. If we apply all these same concepts of ecological thinking, we come up with something called integrated multi-trophic aquaculture. It's a mouthful for ecological fish farming. And if you want to learn more about using ecology to our benefit, check out our friend Andrew Millison again and his work on permaculture ponds. Brilliant. I can't recommend his channel enough. Now, ecology is a crucial aspect of cleaning up water, but so is water flow and being able to capture the nutrients that do inevitably fall into our water systems. And skimmers or intake bays are a fantastic way to do this. They can be on a small pond, as you can see in this illustration, just a small little skimmer on the side of this ecosystem pond, which, as you see, has plants and fish and waterfall. That moving water is vital for water quality. This system was developed by Aquascape, which I'm a proud certified contractor through Aquascape. And if we travel to their headquarters at Aqualand, it's just an amazing sight to see. This pond in the front was all built. And yes, you can swim in it. There's a swim tunnel, and you can jump off that rock. Ask me how I know. Woo! Now, natural swim ponds are a great alternative to traditional chlorine swimming pools that use all these concepts that we've mentioned. Skimmers, aeration, wetlands. They can keep the water clear. It's fantastic to swim in. Now, how can you apply all this stuff in your life? Well, my friend Christoph was asking me the same question. He just got a new farm out in Maine. And you can see in the pond, you got a lot of runoff from the farm. We can see some of the slope here. The previous owner actually used to have a golf course, which all those soluble fertilizers just lead to an explosion of growth in the water. So we got to make a few changes. It's always important to understand the context before we move forward. So let's take another look at the land. We got a farm nearby. It's like we got a natural swale in here where all that water is accumulating. So what do we do? Let's do a quick site analysis. This is by no means definitive. I have never actually been to this site. Every site needs a a detailed in-person walkthrough before you can actually make changes. But here's what I came up with based on my conversations with Christoph. He really wants to collect rainwater from his barn. We can put an aqua basin here, like the one used to gather drinking water in Ghana. And those aqua basins are modular. You can actually put a waterfall on top of it if you'd like. So that can be a future project. We can water the gardens from it. Then we gotta think about access. How do we get all around? And that's really dictated by shape. And the access also influences water movement. So if you remember the shape of the land, that's kind of a basic layout to get around. And then let's plant trees everywhere. You can never have enough trees. Plant them bare root, plant them dense. Some of them are gonna die. That's okay. That's part of natural succession. The trees will filter everything that's coming down and provide a ton of beauty and yields. Then when we look to the pond, we're gonna need some aeration. Some of those big lake fountains would be a good first step. And then we really wanna plant the entire side with marginal plants like water lilies and sedges and rushes and Joe Pye weed and cardinal flower and all sorts of pretty stuff. Eventually we can put in an intake bay to draw the water in, and we can push it. That's to be determined. Maybe he wants maybe a little cottage over here, so maybe you could have a waterfall over there, a little beach, or we could use this interesting peninsula. Now if we get really crazy, we could do a floating walkway where we have a garden all the way in the pond, and we could use that to clean up the pond. So I know that was a lot of information. Hopefully you found some of it useful. If there's anything you want me to dive into more detail, I'm happy to. I plan on making a lot more videos. So drop a comment, let me know what you think and what else you want to hear me talk about. If you've got a particular property that you want me to take a look at, reach out, emails in the description. And don't be afraid to just dig in.